All right, in today's lesson here, we're going to look at the integral of 1 minus cos of 2x divided by 1 plus the cos of 2x, all with respect to x. We'll take a look at a couple of integration involving trig here. This is our first one. So first thing you want to do is use your identities. We know that the cos of 2x, I can express that as 2 cos squared x minus 1. So I'm going to go ahead and substitute that into this integral to try to break this down. So, and the reason why I chose the cos of 2x here is we get a bit of cancellation with at least one of the ones here. It turns out the one in the bottom will get canceled off. Let's take a look at what happens here. This will be the integral of 1 minus, and I can get rid of the cos of 2x and change it to 2 cos squared x minus 1. And the bottom here, I can again get rid of the cos of 2x, and this will be 2 cos squared x minus 1. Again, that's with respect to dx here. So we'll take the integral of, this ends up being here 2 minus 2 cos squared x. Just collecting the constant terms up here, and then like I had discussed earlier, these ones will cancel, and I'm just left with 2 cos squared x dx. And you can see here I can factor 2 out of the top and bottom. This will end up being the integral of 2 times 1 minus cos squared x over 2 cos squared x, again with respect to x. Continuous on here, the 2's will cancel. We're just left with the integral of 1 minus cos squared x over cos squared x with respect to x, but that's exactly equal to sine squared x over cos squared x dx, which is the integral of tan squared x dx. Now you want to go ahead and take the integral of tan squared x to dx, but recall we have the identity here, and we know the tan squared of x is equal to secant squared of x minus 1. If you can't see why, this is equal to 1 over cos squared x minus 1, which is equal to 1 minus cos squared x over cos squared x, which is equal to sine squared x over cos squared x, which is equal to our tan squared x that we had gotten here. So just to show you guys that we do have this relationship where the tan squared of x is equal to secant squared of x minus 1. I'm going to replace that. This becomes the integral of secant squared x minus 1 dx, and that'll be the integral of secant squared x dx minus the integral of just dx. And now if we continue this up here, we know that the derivative of tan x is secant squared of x. This is going to end up being the tan of x minus x plus our some constant, in this case some constant here, k. So again, application of this identity here was a bit unique, just easier to take the integral of secant squared of x, so I went ahead and applied that. All right, so for the first question here, we have the integral of 1 minus cos 2x over 1 plus cos 2x dx is equal to the tan of x minus x plus some constant k. Let's take a look at another integral involving trig identities. All right, for the next one here, we want to take the integral of cosecant x secant x with respect to x. This is multiplication here. First thing to do here is go ahead and write this in terms of sine and cos. This is going to be the integral with respect to x of sine x over cos of x. And what I'm going to do here is this is really equal to 1 over sine x cos x dx. I'm going to go ahead and replace that 1 with a sine squared x plus cos squared x all over sine x cos x dx. And now because of that little trick I did there and kind of rewrote this, I end up getting this as sine squared x over sine x cos x dx plus the integral of cos squared x over sine x cos x dx. And we can simplify this to become, you're going to lose one of the sines here, and here I'll lose one of the coses. So this is going to end up just being sine over cos. This will be sine x over cos x dx plus the integral of cos x over sine x dx, which is exactly equal to the integral of tan x dx plus the integral of cotangent x dx. So now if you want to go ahead and take the integral of tan of x, that is equal to negative ln of the cos of x plus the integral of cotangent of x is going to be the ln of the absolute value of sine of x plus some constant term. Okay, just a quick demonstration here. The reason why, if you go to take the derivative with respect to x of the ln of, let's say, the cos of x, you know that's going to be 1 over the cos of x times the derivative of, chain rule kicks in, the derivative of cos of x is negative sine of x, which is negative tan of x. So we hit this with a minus sign in front. I guess I should put it right here. Making this positive, and getting the value we wanted here. And a similar technique, I should say, you do here to show that you actually do a cotangent of x. So it turns out that if we go to take the integral of cosecant x secant x, it is negative ln absolute value cos x plus ln absolute value sine of x plus some constant value k. So I just wanted to go ahead and do a couple of integrals involving trig identities, and here they are. Thank you.